Learning goals. Welcome to this learning session on chemical formulae, elements, compounds, and ions. In this course, we shall address chemical formulae, elements, atoms and symbols, molecules, compounds and their formulae, ions, types and polyatomic forms, writing ionic compound formulae, interpreting complex formulae with brackets. There will be a quiz at the end to test your knowledge.
Introduction to chemical formula. Chemical formulae are a concise way to represent the composition of chemical substances using symbols and numbers. They provide essential information about the types of atoms present and their relative proportions within an element, compound, or ion. Understanding these formulae is fundamental to chemistry, allowing scientists to communicate complex chemical information efficiently. This course will equip you with the skills to recall and interpret these essential chemical notations. Defining elements and their properties. An element is a pure substance consisting of only one type of atom, characterized by having the same number of protons in its nucleus. Each element possesses unique chemical properties that distinguish it from all other elements. There are currently 118 known elements, with 94 occurring naturally on Earth. The remaining elements have been synthesized in laboratories, often for only fleeting moments, expanding our understanding of matter. Chemical symbols, universal language. Every element is assigned a unique chemical symbol, which serves as its abbreviation in chemical notation. These symbols are standardized globally, ensuring clear communication among scientists worldwide. The rules for writing chemical symbols are precise. They consist of one or two letters. The first letter is always capitalized. Any subsequent letters are always lowercase. For example, the symbol for mercury is Hg, and for oxygen it is O. Atoms, the smallest chemical unit. An atom is defined as the smallest particle of an element that still retains the chemical properties of that element. It is the fundamental building block of all matter, whether solid, liquid, or gas. Atoms are incredibly tiny, with diameters typically around 0.1 to 0.5 nanometers. Despite their small size, they are composed of even smaller subatomic particles, protons, neutrons, and electrons, each playing a crucial role in determining an atom's identity and reactivity. A molecule is formed when two or more atoms are chemically bonded together. These bonds can occur between atoms of the same element or between atoms of different elements, creating a vast array of substances. Many elements that exist as gases at room temperature, such as hydrogen and oxygen, naturally occur as diatomic molecules. This means two atoms of the same element are bonded together, represented by formulae like H2, N2, O2, F2, and Cl2. Compounds, distinct chemical entities. A compound is a substance formed when two or more different elements are chemically bonded together in fixed proportions. Unlike mixtures, compounds have unique properties that are distinct from the elements they are made from. For instance, water, H2O, is a compound formed from hydrogen and oxygen, but its properties are vastly different from either gaseous hydrogen or oxygen. There are millions of known chemical compounds, each with its own specific formula and characteristics. Interpreting compound formula. Chemical formulae for compounds provide a precise count of each type of atom present in one molecule of that compound. The elemental symbols indicate the types of atoms, and subscripts denote the number of atoms. For example, the chemical formula for methane is CH4. This formula tells us that one methane molecule contains one carbon atom, no subscript means 1, 4 hydrogen atoms, indicated by the subscript 4. This totals 5 atoms in one methane molecule. Ions, charged particles. An ion is a charged particle formed when an atom or a group of atoms either loses or gains electrons. Atoms are naturally neutral, with an equal number of protons and electrons, but this balance can be disrupted. The loss or gain of electrons results in an imbalance between positive protons and negative electrons, giving the atom or group of atoms an overall electrical charge. This charge is crucial for understanding how ionic compounds form and interact. Cations and anions, types of ions. Ions are categorized into two main types, cations and anions. Cations are positively charged ions, typically formed when metal atoms lose one or more electrons. For example, a sodium atom loses one electron to become a sodium ion, Na+. Anions are negatively charged ions, usually formed when non-metal atoms gain one or more electrons. The charge of an ion is indicated by a superscript at the top right of its chemical symbol, showing the magnitude and sign of the charge, e.g., plus for a single positive charge, for a single negative charge. Polyatomic ions, groups of charged atoms beyond single-atom ions. There are also polyatomic ions, which are groups of two or more atoms covalently bonded together that carry an overall electrical charge. These ions act as a single unit in chemical reactions. A common example is the sulfate ion, represented as SO4 This formula indicates that the ion consists of one sulfur atom and four oxygen atoms, all chemically joined, and the entire group carries a 2 negative charge. Understanding these complex ions is vital for writing accurate chemical formula for many compounds. Writing ionic compound formula. When writing the chemical formula for an ionic compound, the goal is to achieve electrical neutrality. The total positive charge from the cations must balance the total negative charge from the anions. This often involves finding the least common multiple of their charges. For example, in sodium sulfate, a sodium ion Na+ has a single positive charge, while a sulfate ion, SO4 has two negative charges. To balance these, two sodium ions are needed for every one sulfate ion, resulting in the formula Na2SO4. Interpreting complex formulae with brackets. Some chemical formulae use brackets to indicate that a group of atoms, often a polyatomic ion, is present multiple times within the compound. The subscript outside the bracket applies to everything inside it. Consider magnesium hydroxide, MgOH2. This formula tells us there is one magnesium atom. The OH2 indicates that there are two hydroxide ions, meaning two oxygen atoms and two hydrogen atoms in total. This multiplication is crucial for correctly counting atoms in complex structures.
Summary. Well done, you have completed the course, Chemical Formulae, Elements, Compounds, and Ions. You should now be familiar with chemical formulae, elements, atoms, and symbols, molecules, compounds, and their formulae, ions, types, and polyatomic forms, writing ionic compound formulae, interpreting complex formulae with brackets. Should you need to revisit any of the topics in this course, please use the menu at the bottom of the screen.